So today I am explaining the theory part here. This is very important for the JEE examination here. Okay, because every year there will be one example on this theory here. Okay, so the consistent system here. These are the linear equations here. A system of equations is said to be consistent if its a solution one or more exists here. If it has a solution, it may be one solution or more solution, then it is said to be consistent system here. Then in a consistent system, a system of equation is said to be inconsistent if its a solution does not exist here. Okay, if the system of equation does not have any solution, in that case this system is said to be inconsistent here. Next, the solution of linear equations by the matrix method here. Here there are two methods here. One is a matrix method and one more is a Cramer's rule here. But I will explain about the matrix method here. So the system of equation can be written in this form: Ax is equal to b. The system of equation can be written as Ax is equal to b, where A is equal to, write only coefficients here: A1, B1, C1, A2, B2, C2, A3, B3, C3. This is square matrix here. And a column matrix X equal to X, Y, Z. These are the variables here. Column matrix here. And B is equal to right side terms here. D1, D2 and D3 constants here. Okay, right in the again column matrix here. Therefore, every system of equation can be written in this form here. Then its solution is given by X is equal to A inverse into B here. So here X equal to A inverse into B is the solution here. Therefore, A inverse is equal to 1 upon determinant of A into adjoint of A. So use this one here. So X equal to 1 upon determinant of A into adjoint of A into B here, into this B. Okay, where determinant of A is not equal to 0, means it is a non-singular matrix here. If determinant of A is not equal to 0, then it is said to be non-singular. Therefore, inverse exists only when it is a non-singular here. So this matrix equation provides a unique solution here. In this case, you will get a unique solution when determinant of A is not equal to 0. If determinant of A is not equal to 0, you will get a unique solution, means only one solution is there. This method of solving system of equations is known as a matrix method here. So remark, if determinant of A is equal to 0, okay, if determinant of A is not equal to 0, you will get a unique solution here. Suppose if it is equal to 0, means it is a singular matrix here. In that case, we calculate adjoint of A into B here. First you have to calculate adjoint of A into B. If adjoint of A into B not equal to 0, actually it is not a 0, it is a O here. O means a null matrix or a zero matrix here. O being a null matrix or a zero matrix here. Adjoint of A into B not equal to null matrix O. Then solution does not exist here. Okay, if this is a not equal to 0, if this is a not equal to 0, and in that case solution does not exist, the system of equation is called inconsistent. Suppose if adjoint of A into B is equal to null matrix here, then system may be either consistent or inconsistent. Either it may be consistent or inconsistent according as the system have either infinitely many solutions. It has infinitely many solutions or no solution here. So if it has infinitely many solutions, then it is a consistent here. Then if it has no solution, then it is a inconsistent here. Okay, therefore the system may be either consistent or inconsistent according as either it is infinitely many solutions or no solutions here. Okay, so this according to the matrix method here. So I am explaining the second method here, that is a solution of linear equations using a Cramer's rule here. Okay, according to this rule, Here take a delta. Determinant of delta is equal to coefficients here. A1, B1, C1, A2, B2, C2 and A3, B3, C3 is the determinant delta here. Okay. Then delta 1 is obtained by replace this first column. This is the first column elements replaced by these elements here D1, D2 and D3. So D1, D2 and D3 here, and these two columns are right as it is here. This is delta 1. And delta 2 is the determinant obtained by just replacing this second column by these elements here D1, D2 and D3. Here first and third column elements keep as it is here. So middle column just replaced by these elements here D1, D2 and D3. Then delta 3 is the determinant obtained by the replacing these elements C1, C2 and C3 by D1, D2 and D3 here. Here first two row columns as it is here. These two columns keep as it is here. Only third column replaced by these elements here D1 and D2, D3 here. So these are delta 1, delta 2 and delta 3 determinants here. Therefore, using these determinants, you can find the x, y, z values here. X gives delta 1 upon delta, y gives delta 2 divided by delta, z gives delta 3 divided by delta. So therefore, this method is called Cramer's rule here. This is a very important and very simple also. Okay, now I am using this method only. So remark first one here. If delta is not equal to 0, just like a previous matrix method here, even here also if delta is not equal to 0, it has a unique solution here. Unique solution means it is a trivial. Okay. If delta is not equal to 0, the given system of equation, it is a consistent here. It is a consistent term and have a unique solution, hence it is said to be trivial. Next, if delta is equal to 0, if delta equal to 0, as well as delta 1 equal to 0, delta 2 is equal to 0, delta 3 also 0. All these determinants are 0. Then the given system of equation is consistent here with infinitely many solutions here. With infinitely many solutions. If it has infinitely many solutions, it is said to be non-trivial here. Okay. Therefore, if delta is 0, as well as all these determinants also 0 here, then system is consistent with infinitely many solutions. It is said to be non-trivial. If delta is equal to 0 and at least one of the determinant delta 1, delta 2, delta 3 is non-zero. At least one of the determinant delta 1, delta 2, delta 3 non-zero, then the given system of equation is inconsistent. Is inconsistent and has no solution here. So these are very important results here. Now I am explaining examples here using this method only. This method is a very simple method. Even you can use this method very easily here. Okay. So the example here. If the system of equations x plus y plus z is equal to 6, x plus 2y plus 3z equal to 10, 3x plus 2y plus lambda z equal to mu has more than 2 solutions, then mu minus lambda square is equal to what here? It is a numerical problem here because they are not given any options here. They are not given any options. It is a numerical problem here. Therefore, it has more than 2 solutions here. If it is a unique solution, then delta is not equal to 0. If it has more than 2 solutions, means infinitely many solutions. In that case, delta is equal to 0, as well as delta 1 equal to, delta 2 is equal to, delta 3 is also 0. Hence, here delta is equal to 0. Delta is equal to 0 implies a determinant here. Write the coefficients here 1, 1 and 1 here. So write a 1, 1 and 1. Then 1, 2 and 3. Then 3, 2 lambda. That is equal to 0. Is equal to 0. Then subtract here means making the term here 0. Therefore, this implies a determinant of. Okay, you can subtract like this also, like this also. Therefore, 1 and 3, 1 minus 1 becomes 0, 2 minus 1 is 1 here, 2 minus 3 gives a minus of 1, 3 lambda, that is equal to 0. In this case, C2 gives C2 minus of C1 here. Then expand this determinant here. So this implies 1 into bracket lambda into 1 becomes lambda minus of 3 ones are 3 here, minus minus plus 3, and 0 into any term is 0 plus 1 into minus 1 is minus 1 minus of 3 ones are 3 here, that is equal to 0. Therefore this implies lambda plus 3 into 1 becomes lambda plus 3 here. This is 0. Minus 1 minus 3 is minus of 4 is equal to 0. Therefore 3 minus 4 is minus 1. Take minus 1 right hand side here. So lambda value is 1 here. Next take delta 1 equal to 0 here. Delta 1 is equal to 0 implies, okay, because it has more than 2 solution means delta 1 is also 0 here. In this case replace this first column by these elements 6, 10 and mu. 6, 10 and mu here. So these two columns are written as it is 1, 2 and 2 here. 1, 3 lambda, but lambda value is 1 here, so replace here. So 1, 3, 1, that is equal to 0. So just replace this first column by these elements 6, 10 and mu here, and these two columns are written as it is here. It is a delta 1 here. Again subtract here, this becomes a 0. So this implies a determinant of 6, 10 mu here, 1, 2 and 2, 1 minus 1 becomes a 0, 3 minus 2 gives 1, 1 minus 2 is a minus of 1, that is equal to 0. Now we expand it here, therefore mu 6 into 2 ones are 2 here, minus of 2, minus of 2 ones are 2. Then the minus of 1, 10 into minus 1 is a minus of 10, minus of mu into 1 becomes a mu. And 0 into any term is a 0 here, so that is equal to 0. Then the minus 2, minus 4, 6 4s are 24 here, minus of 24, take minus inside here, plus 10 plus mu is equal to 0. Minus 24 plus 10 is a minus 14. Take minus 14 right hand side here. So mu is equal to 14 here. Here we want mu minus lambda square here. Therefore mu minus of lambda square. Mu value is 14 here. So right here 14 and lambda value is 1 square here. So 14 minus 1 becomes 13 here. So therefore the required result is 13. Second example, if the system of equations, they are given here, the system of equation where ABC belong to are non-zero and distinct has a non-zero solutions, then which is a correct option here? 4 options are there. Which is a correct option? So here it has a non-zero solution. Then either this is applicable here or this can be applicable. In this case it has a unique solution. In this case it has a infinitely many solutions here. In this example it is the second one is suitable here because RHS is 0, 0 and 0. RHS is 0 means delta 1 is 0, delta 2 0, delta 3 also 0 because you are replacing first, second and third column by these elements here. So in a determinant any row or any column, all the elements are 0, then the value of the determinant is 0. Therefore here RHS are 0 means delta 1 is 0, delta 2 is 0, delta 3 is also 0. So this is suitable here. In this case delta is 0. Therefore delta is equal to 0 implies, in this case delta is equal to 0 implies determinant of write the coefficients 2, then 2a and a, then write here 2, then 3b and b, then write here 2, 4c and c, that is equal to 0. Okay, taking this data is equal to 0, imply write only coefficients of x, y, z here. Then you can make these terms as 0 here. Okay, just subtract each other. So therefore R2 gives here R2 minus of R1 and R3 gives R3 minus of R1 here. Therefore this implies determinant of so write here 2a and a. 2 minus 2 becomes 0. 3b minus 2a. So write here 3b minus of 2a. Then b minus a. b minus a. Then 2 minus 2 becomes 0. 4c minus 2a. 4c minus of 2a. c minus a. c minus a, that is equal to 0. Now you expand this determinant here. So this implies so 2 into, so write 2 into 3b minus 2a into c minus a. 3b minus of 2a into c minus of a minus. Then this into this here. So 4c minus 2a. 4c minus 2a into b minus a. Bracket complete here. Then 2a into minus of 2a. 0 into this term is 0. 0 into this term is 0. Then plus a. Plus a into bracket. 0 into this term is 0. And 0 into this is also 0. That is equal to 0 means complete these two term becomes 0. Okay, do it here. Next take this to right hand side here. Again here 0 divided by 2 becomes 0. Take a right hand side, it becomes 0. Just multiply the terms here. So this implies 3b into c. 3bc here. 3b into a minus of 3ab. Minus 2 into c minus of 2ac. Minus into minus becomes a plus here. So 2a square. Write all the terms in the bracket here. Then a minus here. Again multiply the terms here. 4c into b. So 4bc here. 4c into minus a. Minus of 4ac minus 2 into b minus of 2ab minus 2 into minus a, so plus 2a square, that is equal to 0. Take a minus inside the bracket here. Yes, this implies 3bc minus of 3ab minus of 2ac plus 2a square here. Take a minus inside here, minus of 4bc, then a minus into minus becomes a plus 4ac, minus into minus becomes a plus 2ab here, minus into plus is a minus of 2a square, that is equal to 0. Here plus 2a square and minus 2a square get cancels here. Okay. Then so 3bc minus of 4bc here. So minus bc. So right here minus of bc here. Minus 3ab. Then plus 2ab is there. minus of AB. 3AB minus 3AB plus 2AB becomes a minus of AB. Okay, then minus 2AC plus 4AC gives 2AC plus 2AC is equal to 0. Take these two terms right hand side here. 2AC is equal to, so BC plus ABL minus becomes a plus here. Then dividing both sides by ABC here. Dividing both sides by each term by ABC. Hence this upon this here. AC and AC cancels, then remaining is 2B here, 2 upon B. BC and BC cancels, 1 upon A plus AB upon AB. AB cancels, 1 divided by C here. So 2 divided by B is equal to 1 upon A plus 1 by C here. Therefore, here this can be written as 1 upon B is equal to 1 by A plus 1 by C divided by 2 here. Just cross multiply. Then this is arithmetic mean here. Therefore, we can write here 1 upon A, 1 upon B, 1 by C are in AP according to arithmetic mean formula. Therefore, here third option is correct here. 1 by A, 1 by B, 1 by C are in AP.